Look at this giant donut-shaped region far away from Earth, beyond the orbit of Neptune. We're talking about a distance of more than 2.5 billion miles. It's the Kuiper Belt, and something eerie and bizarre is happening there. Dwarf planets and other small objects dwelling there refuse to cluster together. Instead, they follow particular orbits, which is weird. The reason might be a large, mysterious planet hiding beyond Pluto. Its gravity might be messing up the orbits of those Kuiper space bodies. Hear me out. Our solar system is made up of the Sun and everything that goes around it because of the star's strong gravity. This includes the 8 main planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are also smaller things like moons, asteroids, and Pluto. For a long time, people thought Pluto was the 9th planet, but when it was reclassified as a dwarf planet, scientists started looking for a new Planet X. Did they have a thing about odd numbers or what? And guess what? Some really think there might be a big, icy planet hiding far, far away beyond Neptune. This mystery planet is often called Planet 9. Now, Planet 9 hasn't been seen yet, but scientists think it might be out there because of some tiny, faraway space rocks called etnos that move following bizarre, confusing paths. These paths seem to be grouped together and tilted in a way that doesn't happen by chance. This could mean there's a hidden planet pulling them into place with its gravity. If Planet 9 is real, it might be 5 to 10 times heavier than Earth. It would also be super far away, hundreds of times farther from the Sun than Earth is. Over the years, scientists have guessed different distances for its orbit, and the newest guess in 2025 says it could be about 290 times farther from the Sun than Earth. There are some cool ideas about where Planet 9 came from. It might have started as a big planet that Jupiter once kicked out of the inner solar system, or it might have come from another star or even wandered around space on its own before getting caught by the Sun's gravity. Even though scientists have looked really hard using powerful telescopes, no one has actually seen Planet 9 yet, and so far, its existence is still just a theory. But recently, a group of researchers tried something clever. They used data from 2 special space surveys called ERAS and ACARI. These 2 looked at the sky in invisible light, far infrared, about 23 years apart, which is helpful because Planet 9 is supposed to move very slowly. The team focused on a special list from ACARI, which is better at finding faint, moving things in space. They guessed how bright Planet 9 might be and how fast it might move based on how big, far away, and cold it could be. Then they looked for matching blips in the sky that were seen by both ERAS and ACARI, but not in the exact same spot. That's because a real planet would have moved a little over 23 years, and they indeed found 13 possible matches that could be Planet 9. Their estimations were based on how far away the object seemed to be, 500 to 700 times farther from the Sun than Earth, and how heavy it might be, which is 7 to 17 times Earth's mass. After looking very carefully at all the images, they narrowed it down to one really good candidate. The 2 detections weren't in the same spot in both surveys, and the way they appeared in the ACARI map matched what you'd expect from a slow-moving object. It showed up on one date and wasn't there 6 months earlier, but of course, there was a catch. Apparently, the old data isn't good enough to figure out the exact path of the potential planet. So, the team wants to do new follow-up observations using a special camera called DCAM, which is really good at spotting faint, moving objects. That way, they can find out if this candidate is really Planet 9. Additionally, it can help us learn more about how our solar system works and how it formed. If Planet 9 is ever discovered, it would totally change the way we understand our solar system. It could explain why some far-out space rocks in the Kuiper Belt tilt weirdly. The thing is, most planets go around the Sun in a flat-ish circle. But those faraway objects are tilted about 20 degrees. Planet 9 might be the reason why. Next, we'd probably find out why those tilted objects seem to point the same way. Their orbits are grouped together in one direction. A big hidden planet's gravity could be hurting them like sheep. There are also some strange tilted objects super far away. They don't make sense unless something big, like Planet 9, is tugging on them. A few space rocks orbit the Sun backward between the big planets, which is kinda the wrong way. That's super weird unless something big is messing with them. Some far-out Kuiper Belt objects keep crossing Neptune's path and haven't been flung away. That's because Planet 9 might be helping keep their orbits stable over a long time. Another cool thing is that if Planet 9 existed, it would be a super-Earth, a kind of planet we see a lot around other stars, but we don't have in our solar system yet. So finding one here would make our solar system more like the others out there. Throughout history, people have been wondering if there could be hidden planets far beyond Neptune, even before Pluto was found. Back in 1880, a guy named George Forbes guessed there might be two unknown planets way out there, one about 100 times farther from the Sun than Earth, and the other about 300 times farther. He thought these mystery planets might be pulling on some comets and changing their orbits, kind of like how Jupiter does with the comets near it. In 2004, scientists found a weird little world called Sedna. It had a strange path around the Sun that didn't seem to be affected by any of the known planets. Its closest point to the Sun, called perihelion, is way too far for Neptune to be the reason. This made some scientists wonder if Sedna got pushed into its path by a hidden planet, maybe even something as big as Earth or bigger. Others thought maybe it was a star that flew by a long time ago, or another star that formed near ours. Then, in 2014, another odd object was discovered. It had a very similar orbit to Sedna, which made people even more suspicious that there could be something big out there messing with their paths. This kicked off a new round of the Planet X or Planet 9 hunt. At a meeting in 2012, a scientist named Rodney Gomez said that maybe there was a big, hidden planet around 1,500 times farther from the Sun than Earth. He thought it could explain the orbits of other odd objects, like some far-out comets and centaurs, small bodies that wander among the giant planets. At that time, those who supported the Planet 9 theory believed that if it existed, it would move around the Sun in a huge, stretched-out circle called an elliptical orbit. It would be about 400 to 800 times farther from the Sun than Earth is, about 13 to 26 times farther than Neptune. If it really had that kind of orbit, it would take around 10,000 to 20,000 years to go around the Sun just once. Plus, if it indeed orbited the Sun, it wouldn't follow the same flat path as the other planets. Its path would be tilted by about 15 degrees to 25 degrees. The farthest point in its orbit, called aphelion, would be in the direction of the Taurus constellation. As for the closest point, it would point towards Serpens, Ophiuchus, or Libra. As for the composition of Planet 9, it would probably be a lot like Uranus or Neptune. It would have a thick atmosphere made of hydrogen and helium, and it would be super cold, negative 375 degrees Fahrenheit. Its core would be made of iron, and its middle layer would be full of rock and water ice. At the same time, if the planet was smaller and denser, then it might be more like Earth, with a rocky surface instead of a gassy one. According to a scientist named Mike Brown, if Planet 9 was real, a space probe would reach it in about 20 years if we used a powerful slingshot path around the Sun.
So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So, what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptune or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggest it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler 186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler 186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. So, in the end, will the Sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the Sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask. But for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances, and somehow life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years. A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, what could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon, triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop. More dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, it's too early to claim that Ariel still has a huge ocean today. It's small, and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now. But it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot. So the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs. It may seem like the best way to get to some planet from Earth is to patiently wait for it to come as close as possible. Yeah, there it is. And then take off on a rocket pointed in the planet's direction. Whoa, bye Mom, see ya. Wait, why didn't this method work? First off, the planets, including our own, constantly move following their elliptical orbits at speeds of tens of miles per second. So your rocket kind of needs to be put in an elliptical orbit, right? Kind of like aiming a dart at a moving target, or throwing a surprise party for your friend. You don't want the surprise to come at the wrong moment. Also, when we send spacecraft to other planets, we want to use as little energy as possible. And to get to any planet out there in the easiest way possible, you actually need a special trick called the Hohmann transfer orbit. Let's say you want to travel to Mars. You have to wait until Earth and the red planet are in the right positions, so you don't get lost up there or run out of fuel somewhere halfway. Traveling there using a Hohmann transfer orbit would take about 259 days. That's because the transfer orbit between Earth and Mars takes 517 days to complete a full orbit, and the trip to Mars covers half of that orbit. Couldn't you just travel faster? Well, yeah, but that would waste way more fuel, which would make the launch more complicated, since the rocket would be too heavy. Basically, it would be like a dog biting its own tail. If you could travel at the speed of light, it would take you 12.5 minutes. Also, when your rocket finally gets to the other planet, it still needs to slow down to go into orbit around it, or even land on its surface. This means it will use more energy. But you can try to use as little as possible and maybe go with things such as parachutes or aerodynamic braking. It's kind of like if you were riding your skateboard and needed to stop. You wouldn't just crash into a wall. You'd use your foot or something to slow down gradually. Traveling to Venus is a bit quicker. It would take you about 146 days. That's not bad. But the problem is you'd still need to wait for about 2 years before coming back to Earth. That's necessary because the planets need to realign themselves properly so that the spacecraft can meet Earth's orbit when it returns. So, in total, a round trip to Venus would take around 2 years and 1 month, including the waiting time. And that waiting time wouldn't be that pleasant, considering that's the hottest planet in our solar system. Let's say you want to travel to Jupiter. How long will that take? It depends on a lot of things, mainly its position. Plus, how fast are you traveling? If you want to use the best technology we have right now, you should know that it took the fastest spacecraft ever built, NASA's New Horizons, just over a year to reach Jupiter. But keep in mind that the New Horizons mission was just a flyby. The spacecraft didn't actually go into orbit around Jupiter. If you wanted to stay in orbit and explore Jupiter up close, it would take way longer. So definitely not a weekend trip. Using the Hohmann transfer, you'd need several years to get to Jupiter. That's because a Hohmann transfer puts focus on transferring an object from one orbit to another. Jupiter is in a higher orbit than our home planet. So, to finish the transfer, your rocket would need to travel along a path that would take it past the orbit of our gas giant. So the rocket would need to speed up when it gets closer to Jupiter to avoid falling back towards the sun, and then slow down when it passes Jupiter to avoid flying off into space. It's like a car speeding up to climb a hill and then slowing down as it goes down the other side. This is how the spacecraft uses the gravity of Jupiter to move into orbit around the gas giant. It's hard to tell the exact distance between Jupiter and Earth. They're both traveling around the sun in different oval-shaped paths. Sometimes they get really close to each other, and other times they're really far apart. It's like they're playing tag. But on average, they're 444 million miles away from each other. When Jupiter is farthest away from Earth, it's a whopping 601 million miles away. That's like driving around the entire Earth 24,000 times. But if you could travel to Jupiter at the speed of light, on average, you'd get there in 40 minutes. There's this super fast spacecraft we need to mention, the Parker Solar Probe. Imagine you're on a really fast roller coaster, moving at incredible speeds that are hard to fathom. The roller coaster would actually be our Parker Solar Probe. It's flying closer and closer to the sun, breaking speed records along the way. During its 10th close flyby of the sun in November 2021, the Parker Solar Probe managed to reach a top speed of more than 360,000 miles per hour. That's like traveling around the whole Earth in several minutes. And get this, when the spacecraft gets even closer to the Sun in December 2024, it's expected to reach a speed of 430,000 miles per hour. Yep, not a good idea to have a big lunch before this roller coaster. Now, let's say you're on the Parker Solar Probe and you want to take a detour to visit Jupiter. If you were able to travel in a straight line at the same speed the Parker Solar Probe was going during its 10th flyby, it would only take you 42 days to reach Jupiter at its closest approach. On their average distance, you'd need a little bit longer to get there, 51 days. You'd also have to consider the duration of your trip. There are two ways your rocket can arrive at a planet, either by going into orbit around the planet or by just flying by really fast. If the spacecraft is supposed to go into orbit, it needs to slow down when it gets close to the planet. Imagine it gets captured by the planet's gravity and starts going around it. Better to slow it down when it arrives then. And this means burning lots of extra fuel and making your trip longer. Here's something interesting. To travel faster, we can use something called gravity assist. That means we use the gravity of planets and other objects in space to give us a little push and speed our precious rocket up. That's how the Voyager spacecraft were able to travel to Saturn and beyond. But even with a gravity assist, it still takes a really long time to travel to other stars. For example, the star that's closest to us is Proxima Centauri, and it's still 4.2 light-years away. Let's change the method now compared to the previous examples. If we traveled at the same speed as Voyager 1, it would take us 75,000 years to get there. If you prefer to take a trip to Uranus, know that the distance goes up to 2 billion miles, depending on the spot where the planets are during their orbits. It took about 9.5 years for Voyager 2 to reach Uranus. But Uranus is cold, and as an ice giant, it doesn't even have a real surface to land on. Most of the planet is swirling fluids anyway. Not only would you have nowhere to land there, but your rocket would hardly even manage to pass through the atmosphere of Uranus unscathed. The temperatures and pressures are extreme up there and would just destroy your entire metal spacecraft.
Shh! The planets and the moons in our solar system are hiding secrets that could change our knowledge of Earth itself. Uranus stores heat we didn't expect. Mercury has been shrinking and cracking for billions of years. Jupiter's moon, Io, emits giant columns of volcanic plumes. These cosmic mysteries hint at forces and processes that could, one day, ripple through the solar system and even affect life here on our own planet. Back in 1986, Voyager 2 flew by Uranus and confused everybody. The readings showed the planet wasn't giving off any extra heat. This made it look totally different from the other giant planets in the solar system. That was strange because Jupiter, Saturn, and Neptune all release way more heat than they take in from the Sun. Fast forward a few decades, and two independent research teams went back through a mountain of observations. What they found changes the story. Uranus does give off more heat than it receives. About 12.5% more to be exact. The two studies show that Uranus is still slowly releasing leftover heat from its early days. That detail matters greatly because it helps scientists piece together the planet's origins and how it's changed over time. As for Voyager 2's odd readings, they now make more sense too. The flyby happened when the Sun was unusually active, which made Uranus act weird, so those early numbers likely didn't reflect its normal state. Even so, Uranus still stands out. Jupiter pushes out 113% more heat. Saturn gives off 139% more, and Neptune tops them all at 162%. And since Neptune is farther away from the Sun, distance isn't the reason Uranus is cooler. Something unique is happening deep inside. Maybe the planet's structure is different, or maybe its past somehow shaped it in another way. Another weird space body in our solar system is Jupiter's moon Io. Oh, by the way, did you know that Io has a brother moon named EIE? So, through a telescope looking at Jupiter, you can sometimes see them. E-I-E-I-O, right next to Old MacDonald. Hey, I thought it was funny. Anyway, back in 1979, Voyager 1 zipped past Io and saw something jaw-dropping. Giant volcanic plumes were blasting straight into space. It was the first time humans had ever seen active volcanism beyond Earth. Io looked wild, and ever since then, scientists have been trying to figure out what makes this little moon so ridiculously volcanic. For decades, one leading idea was that Io hid a global magma ocean just under its crust. That would explain why volcanoes are scattered pretty evenly all over the surface, as if they're feeding off the same underground reservoir of molten rock. NASA's Galileo spacecraft even seemed to back this up in the 1990s and early 2000s. Its magnetometer picked up a weird magnetic signal that looked like it came from a huge electrically conductive layer, basically liquid rock. By 2011, the consensus was that Io was sitting on a magma ocean several dozen miles thick. But now that theory has been flipped on its head. NASA's Juno spacecraft has been looping around Jupiter since 2016, and in late 2023 and early 2024, it made a couple of super close flybys of Io. The main goal was to figure out what was going on inside. Juno carries a super precise radio transponder that scientists use like a stethoscope. Io's gravity field tugs on the spacecraft ever so slightly, changing the radio signal. By mapping those tiny shifts, the team can see how mass is distributed inside Io. The verdict is there's no shallow magma ocean sloshing under the crust. Otherwise, Juno would have picked up way more distortion in Io's gravity field as Jupiter's tidal pull flexed the moon. But the data showed nothing of the sort. This leaves planetary scientists with a big puzzle. If there's no magma ocean, what's powering the most volcanically active body in the solar system? Io's volcanism is likely driven by tidal heating, because Io's orbit is a little stretched out by the gravitational tugs of neighboring moons. Jupiter constantly squeezes and releases this little world. The crust can rise and fall by as much as 330 feet, and all that flexing creates frictional heat inside the moon. Tidal heating does make magma, but if it's not pulling into a giant ocean, maybe it's stored in smaller scattered reservoirs within the crust. On Earth, different magma chambers feed different styles of volcanoes, but since Io doesn't have plate tectonics, it probably doesn't have the same variety. The new results don't totally rule out a deep magma ocean buried way below the crust. But if that exists, it would be so dense and iron-rich that it wouldn't rise easily to the surface. At that point, it's hard to tell whether we'd even call it a magma ocean or just a molten core. Now, at the same time, Jupiter's moon Europa, for example, is also tidally heated. But in its case, the heat likely sustains a salty liquid water ocean beneath an icy shell. Saturn's moon Enceladus is another great case. The Cassini spacecraft not only found signs of a hidden ocean, but even flew through plumes of water erupting from its south pole. So why does tidal heating make water oceans on some moons, but not magma oceans on Io? The thing is, magma is lighter than solid rock, so it wants to rise and erupt quickly instead of sticking around in one giant pool. Water, on the other hand, is heavier than ice, so it sinks and collects into a stable ocean beneath the crust. That's why magma oceans are so hard to sustain, while water oceans are relatively easy. In any case, even though tidal heating may not be great at making magma oceans, it's excellent at making water oceans. And since water is the key ingredient for life, moons across the solar system, Europa, Enceladus, and maybe others too, could be hiding habitable environments beneath their icy crusts. Io might be a volcanic inferno, but it's helping scientists figure out where else we might actually find life in our solar system. Now, let's move closer to Earth and explore Mercury. Believe it or not, this planet and our favorite pastries have something in common. They both shrink as they cool. Mercury formed about 4.5 billion years ago, and ever since then, it's been slowly losing heat. As the planet cools, its rocky shell contracts, just like a cheesecake or cookie that cracks when it comes out of the oven. Mercury develops fractures in its crust. These show up as thrust faults. giant cracks that push up sections of the planet's surface to make room for its shrinking interior. By looking at how those faults have lifted up Mercury's terrain, scientists can figure out how much the planet has shrunk over time. But earlier estimates were all over the place, ranging anywhere from less than a mile to more than 4 miles of lost radius. That's a pretty big range. So figuring out a more precise number has been a long-standing puzzle. To tackle the problem, researchers tried a new way of measuring Mercury's shrinkage. The old method used the length and height of uplifted landforms, but the results shifted depending on how many faults you counted in the dataset. More faults, one answer. Fewer faults, a different answer. That inconsistency made things messy. The new method avoids that issue. Instead of relying on every single fault, it focuses on the biggest one in the set. It's like finding the biggest crack in a cookie and using it as a baseline to estimate how much the whole thing cooled and contracted. Now, to test this, the researchers ran their method on 3 separate datasets. One had 5,900 faults, another had 650 faults, and the last one had just 100. And no matter which dataset they used, the results stayed consistent. Mercury has likely shrunk by about 1.2 to 2.1 miles due to faulting alone. But the planet didn't just get smaller because of its cracks. Scientists added shrinkage from other cooling processes to their fault-based results and found that the planet has gotten up to 3.5 miles smaller since it first formed. These new numbers don't just show how much Mercury shrank, they also give clues about its thermal history. They tell us how fast it cooled, how its interior changed over time, and how its crust reacted to that cooling. And this method isn't just for Mercury either. Researchers think it could also be used to study tectonics on other planets, like Mars, which has faults on its surface too. Well, the space object 3I Atlas just whipped past the Sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey Telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way. And that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonol, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh.
Hundreds of diplomatic spaceships take off from Earth and head into space. When they reach their destination, they're met by hundreds of alien ships. This is humanity's first contact with an extraterrestrial civilization. People managed to detect them not so long ago, in a star system very close to our home. It's Proxima Centauri. This red dwarf star is the closest to our solar system. It's 7 times smaller than our Sun, which makes it only 50% bigger than Jupiter. Proxima Centauri is also 8 times as light as the Sun. This star system is 4.2 light-years away. That's how long it takes a photon of light to travel from this star to Earth. By comparison, it only takes 8 minutes for sunlight to reach our planet. If you decided to travel to Proxima Centauri, it would take you about 73,000 years to fly there in a conventional rocket. That's longer than our intelligent civilization has even existed. But it's not the star itself that interests us. It's the planet orbiting it. That's Proxima Centauri b. It's 17% bigger than Earth and about 10% heavier. It orbits its star at a distance of 4.5 million miles. By comparison, Earth is 93 million miles away from the Sun. That's 20 times farther. But the host star, Proxima Centauri, is a red dwarf. It doesn't emit as much light and heat as our Sun. So the planet Proxima Centauri b is right in the habitable zone of the star. It's located at such a perfect distance from its mother star that the planet neither gets too hot nor turns into a block of ice. In other words, the temperature there makes it possible for water to exist in its liquid state. This means that Proxima Centauri b could host life. But further observations of the planet make it doubtful. The host star is very unstable. Its brightness changes too frequently. In 2017, astronomers witnessed a catastrophic flash. The star increased its brightness by 1,000 times for 10 seconds. Before that, there was another weaker flash. The planet received an enormous amount of radiation. If there had been life there, that flare would have wiped it out completely. Overall, Proxima Centauri b receives about 400 times more X-rays than Earth. Complex living organisms cannot live under such conditions. Scientists say that even if there was an atmosphere and an ocean on Proxima Centauri b, this constant radiation would simply blow them off the planet. Proxima Centauri b is so close to its host star that it's gravitationally locked to it. This means that the planet is always turned to the star with only one side, just like the moon is turned toward Earth. That means that only one side of the planet receives this awful amount of radiation, and some experts speculate that an intelligent civilization might live on the night side of the planet. And it could be this civilization that sent us the strange signal that astronomers caught in 2019. Scientists described it as, quote, a bright long-duration optical flare, accompanied by a series of intense coherent radio bursts. This radio signal was observed for 30 days by one of the radio telescopes on Earth. Scientists thought the signal was artificial and could have been sent by an extraterrestrial civilization. Presumably, the signal came from Proxima Centauri b. or one of the moons that might be in that star system. But further observations failed to detect the signal. Now, the main theory claims that this radio signal is just some kind of interference from some technology on Earth. But what if it was really sent by a civilization living on the dark side of Proxima Centauri b? Well, we may soon find out for sure. People are launching a brand new telescope into space. It's the James Webb Space Telescope. It's scheduled to be launched at the end of 2021. A booster rocket will take off from Earth and reach orbit. Then, it'll deliver the telescope to a specific point between our planet and the Sun, where their gravitational forces are roughly equal. Plus, there's no light pollution in space, unlike on Earth's surface. There are also no clouds or other weather conditions that might interfere with the telescope. The James Webb Space Telescope will replace the Hubble telescope, which has been operating in space since 1990. The new telescope costs $9.8 billion. And here's why. It'll use a mirror as wide as a boxing ring. This will allow the telescope to see very far into space. So far, in fact, that the light from some events happening there won't have reached Earth yet. This means we will literally be able to look back in time. The James Webb Space Telescope will see the universe almost immediately after the Big Bang. We'll see how the first stars and galaxies were born, and how the universe turned into what we observe today. But also, this telescope can be used to examine Proxima Centauri b. Astronomers will be looking for artificial light there, like the LED lights we have on Earth. If Proxima Centauri b really hosts life on its night side, then the locals must have learned to transfer heat and light from the day side of the planet, and they would have to use artificial light to support life on their side. The James Webb Space Telescope is powerful enough to distinguish the light waves emitted by the star from those that might be created by someone on the dark side of the planet. And if we do detect some artificial light, we'll have the first ever confirmation that an intelligent civilization might exist outside our solar system. But there's always room for error in calculations and data interpretation. The only way to establish the truth once and for all is to send a space probe to Proxima Centauri. Then we can get real pictures of the planet. The main problem is distance. Although Proxima Centauri is the closest to the Earth star system, it still takes tens of thousands of years to get there. After all, the Voyager 1 space probe needed about 44 years just to leave the solar system. And that's just a small step compared to the actual distance to the nearest star. So we need other methods of travel, and they have to be much faster. Some scientists want to send microprobes to Proxima Centauri b. They won't be any heavier than a sewing needle. A launch vehicle will deploy about 1,000 of these probes into orbit. Then they will unfold a space sail. This is an ultralight material that will use the power of light to create thrust. When the sail is deployed, we'll focus a powerful laser beam onto it. This will accelerate the probes to about 20% of the speed of light. This will be an absolute speed record by our standards, but it'll still take about 21 years for these probes to reach their destination. And we'll have to wait for about 4 more years just to get the first signal from them. The Proxima Centauri star system isn't the only potential world to host life, and one of the tasks of the James Webb Space Telescope is to look out for other worlds. The telescope's powerful instruments will allow it to find relatively cold planets where temperatures are close to those on Earth. We'll be able to study in detail around 24 nearby star systems, and we'll be able to detect not only planets themselves, but also their moons. Scientists expect a boom in the discovery of exoplanets. From the start of the telescope in 2022, we'll constantly be detecting new worlds and learning more about those already discovered. The James Webb Space Telescope will allow us to better study our own solar system. Jupiter's moon Europa, for example. Scientists believe there might be water there. Although Europa looks like a block of ice, the moon's gravitational interaction with Jupiter heats its core. That likely makes the ice deep below the surface melt. So there's likely to be an ocean under the ice crust. Similar conditions could exist on Enceladus, Saturn's moon. This moon is geologically active. There are geysers that burst out of the cracks on the moon's surface. The James Webb Space Telescope's infrared instruments will be able to explore Europa and Enceladus in search of biosignatures. Those are the traces of life activity of living organisms or bacteria. This telescope is scheduled to operate for about 6 years. But in the future, we'll launch an even bigger one. It's called LUVOIR, which stands for the Large UV Optical Infrared Surveyor. Its mirror will be twice the size of that of the James Webb Space Telescope, and almost 7 times the size of the Hubble's. The telescope is scheduled to be launched in 2039. We'll get it into orbit with the help of a super heavy rocket. Then we'll have to deliver the telescope to its destination, 1 million miles away from Earth. And then it'll begin its observations. We could learn to travel faster than the speed of light by that time. Then, if we find a potentially habitable planet with the help of the telescope, we can send a space probe, or even a team of explorers there. In this case, a diplomatic meeting with an extraterrestrial civilization might become a reality.
During the recent years, scientists made 2 breakthrough discoveries about our universe. Thanks to new technologies, we've looked into the distant past. And we've learned something that can change our understanding of the universe forever. What are these discoveries and what do they mean to us? Let's find out. Recently, we unveiled the first color image from the James Webb Space Telescope. It's a mind-bending photo capturing thousands of ancient galaxies. This oldest documented light in the history of the universe dates back over 13 billion years. That's just 600 million years after the Big Bang. It's like getting a sneak peek into the universe's baby album. But that was just the beginning. Astronomers were expecting to see some tiny young galaxies. But what they found was a real surprise. Impossibly early, impossibly massive, and all that from just a tiny red dot. The lead author of the study, Ivo Laba, was working at the computer as usual, and suddenly he got 2 numbers. Age, 13 billion years. Weight, 100 billion stars. When he realized what that meant, he nearly spit out his coffee. But that red dot was just the beginning. The next day they found 5 more galaxies just like this. Turns out, these 6 massive galaxies are as old as the Milky Way itself. The entire research team was in disbelief. They were like, wait, what? These guys couldn't be that mature so early in time. Did we make a mistake? But nope. The James Webb Space Telescope, the new cool guy on the space block, just has some serious skills. It can see through dust clouds with its infrared vision and spot galaxies that were previously invisible. Move over Hubble. There's a new stargazer in town. But why is it shaking things up so much? Because this discovery affects our understanding of how galaxies formed. Let's try to explain. A long time ago, 13.8 billion years ago to be precise, our universe was born. It was chilling out for a while, and then it started to form the first galaxies. And these galaxies were full of gas and dust. Eventually, this gas started turning into stars. Some galaxies were more massive and had more stars, and some were lighter and had almost no stars at all. In any case, they all grew gradually. The stars in them were born slowly and smoothly. That's how our current models explain this. But these new observations from the James Webb Space Telescope show an unexpected surprise. Looks like, even in the early universe, our ancient friends had lots of stars. More than what we would ever expect. If that's the case, then these galaxies are like the overachievers of the universe. They skipped the small and gradual growth phase and went straight to being giant universe breakers. According to our current cosmological model, they shouldn't even exist. But they do, so it looks like after the Big Bang, the stars were forming much faster than we thought, which is pretty weird. This could mean that there's something missing in our understanding of the galaxy formation. As you can see, these universe breakers are really living up to their name, causing a potential total consensus among scientists. The universe was like, hey, I'm about to flip cosmology models upside down. But let's not jump to conclusions. There are many theories that could explain these mind-boggling discoveries without breaking the standard model. For example, maybe the light we're seeing isn't coming from stars at all, but from the swirling disks of doom around supermassive black holes. These colossal cosmic beasts can gobble up matter and spit out a dazzling light show. And James Webb Telescope's keen eye is picking up on these enigmatic accretion disks like never before. Or maybe these galaxies could be playing hide-and-seek with us. Maybe there's more to the story that we haven't seen yet. After all, the universe is vast and mysterious, and we've only just begun to scratch the surface. And whoa, we really need to slow down here. Before we even try to explain all this stuff, we need to confirm whether these ancient galaxies really are that old. Although even if they're actually just supermassive black holes, it still shows an astounding change. We'll have to wait about a year to find out. One thing's for sure, the James Webb Space Telescope has definitely taught us a valuable lesson. Expect the unexpected. And this is just the beginning of unexpected. Evolab's team wasn't the only one who made such a huge breakthrough. There's also a team that claims that they've unlocked the secrets of the universe's past, and that's worth 2 Nobel Prizes. Move over James Webb Space Telescope, because this discovery came from an antenna that's smaller than a fridge and costs less than $5 million. Talk about space bargain hunting! The astronomers caught this signal that showed some surprises. It was coming from the earliest stars of our universe, back in the days when they were just beginning to twinkle. Say hi to our celestial ancestors again. Now, the signal was pretty weird. The temperatures were unusually low, and there was a pronounced wave that left astronomers scratching their heads. What could be causing all this? Well, there's a theory. Dark matter may have been at work, and if that's the case, then we can really be on the verge of a great discovery. Imagine you're looking at the night sky filled with stars, but there's something else there that you can't see. It's like an invisible cloak that covers the entire universe. Scientists call this mysterious stuff dark matter. Dark matter is like the ghost of our world. It doesn't emit, absorb, or reflect any light. We can't see it with telescopes or our eyes. That's why we call it dark matter. But if we can't detect it in any way, how do we know it exists? Because of its gravitational pull. One day we noticed that our understanding of how galaxies were created was incorrect. According to our calculations, they should have been some chaotic gas, but something held them together, turning them into spirals, like some kind of invisible glue. Then we thought, maybe this invisible glue really exists. If the moon was invisible, we would still suspect that it exists somewhere because its gravity affects the tides on Earth. This is also the case with dark matter. Its gravity influences the motion of galaxies and other cosmic objects. In fact, dark matter makes up a huge chunk of the universe, about 27% of it. Moreover, the normal matter we can see, like stars, planets, and galaxies, only make up about 5% of the universe. So even though we can't see dark matter, there's actually more of it in the universe than everything we can see. Scientists are still trying to figure out if dark matter exists and what it can be made of. Some theories suggest that it could be made up of exotic particles that are different from the particles that we're used to. Others think that it might be some kind of weird, undiscovered form of matter that doesn't interact with light at all. Anyway, it's an intriguing mystery, and if we ever confirm the existence of dark matter, our understanding of our world will change forever. So now you can understand why the excitement in the scientific community is palpable. If this discovery is confirmed, then we will get the first real proof of dark matter. This discovery may be even more important than the Big Bang itself because, as astronomers put it, we are made of star stuff, and so we are glimpsing at our origin. But of course, we still have to wait and explore all this in great detail. In science, one should never rush to conclusions. And while scientists study this stuff, we'll be here, on the edge of our seats waiting for the next space blockbuster to unfold. The universe never ceases to amaze us with its wonders. Who knew that such a small and humble antenna could unlock such cosmic secrets? It just goes to show that in the vastness of space, even the tiniest discoveries can have the biggest impact. Keep looking up, and who knows what other cosmic surprises are waiting to be uncovered.
For what seems like ages, scientists have been hunting for another Earth, perhaps to find cosmic neighbors, or maybe just to have a backup planet for potential relocation in case we can't turn this one around. Now, thanks to the James Webb Space Telescope, they might finally have a strong candidate. It's called TRAPPIST-1e and is located 40 light-years away. 1e orbits a small star called TRAPPIST-1. It's an intriguing system that has 7 Earth-sized planets, all of which are nicknamed with letters from B to H. While 40 light-years won't be reachable anytime soon, that's still close. Well, in space terms at least. Our galaxy, the Milky Way, is about 100,000 light-years across. So compared to that, 40 is like a walk down the driveway. Or at least will be if our spaceships achieve a speed close to the speed of light, just like in the movies. Remember, a light-year isn't a measure for time. It's how far light can travel in 1 year, which is close to 6 trillion miles, which is a lot of zeros. So, multiply that by 40, and you get the location of TRAPPIST-1. So, bring a big lunch. T1 is a red dwarf, a type of star that's basically like a dimmer and smaller version of our Sun. It's only a bit bigger than Jupiter. Among this family, 1e sits in the star's sweet spot, the so-called Goldilocks zone. Not too hot, not too cold, at a distance where liquid water could exist on a planet's surface if it has the right atmosphere. Perfectly habitable, at least for creatures resembling Earth's residents. However, it's not just located at just the right distance, which is a huge plus. 1e also happens to be a rocky planet. Its size and mass are close to Earth's, which suggests it has a similar density and structure, as well as similar gravity, meaning no cool jumps like on the Moon. Now, Webb has picked up hints that there could be an atmosphere. The planet might be wrapped in gases like nitrogen, carbon dioxide, and methane. We have such a mix over here, too. Earth's air is built from the same elements. Atmosphere matters. Mars lost most of it, Venus has too much, and Earth got it just right. That's why we have cozy weather and oceans. If 1e really does have something similar, it could mean clouds, rain, and maybe even seas. The stuff that would make Earthlings feel at home. However, here is where it gets interesting. We mentioned that 1e is a red dwarf star, and that makes it dim, hundreds of times dimmer than the Sun. If you were standing on 1e, the star would look way bigger in the sky than our Sun does here. But it would glow red and dull. It would be like living under a never-ending sunset. You might think, sweet, it would be romantic, until it gets old. I mean cold. It has to be freezing, right? After all, how can such a faint star provide enough heat for life the way our Sun does? Well, funny enough, you won't need super winter-resistant jackets. The trick is distance. TRAPPIST-1e orbits extremely close to its star, just about 3% of Earth's distance from the Sun. If the planet were sitting where Earth is, it would be a ball of ice. But being so close also means that its year is only around 146 hours. That means it takes 6 Earth days for 1e to resolve around T1. Celebrating birthdays every 6 days sounds like a great deal, huh? That's a lot of cake. But wait, does that mean that each season would last about 36 hours? No, because the planet is almost certainly tidally locked. That means one side bakes in endless daylight and the other side is stuck in eternal night. Not exactly Earth 2.0. Without an atmosphere, you'd get a scorched wasteland on one side and an ice cube on the other. But with an atmosphere, the air can spread the heat around, smoothing things out. In theory, the comfiest spot might actually be the twilight strip between day and night, the so-called Terminator line. Again, a permanent sunrise or sunset. Instagrammers would love it. Red dwarfs are actually the most common stars in our galaxy, making up about 70% of all the stars we know about. And they live practically forever. Our Sun is projected to last 10 billion years. Red dwarfs could go on for trillions. That's more than enough time for life to develop. However, the short straw is that red dwarfs are kind of feisty. They erupt with powerful flares that blast out intense radiation. So, for planets orbiting so close, those flares can strip away atmospheres and sterilize the surface. It's like having a dream house with a beautiful view near a dynamite factory. Oops. That's what makes TRAPPIST-1e so exciting. If it does have an atmosphere, it would mean it somehow resisted billions of years of flare activity. And it might not be the only one. There could be plenty of exoplanets like this out there. Now, you may be wondering how scientists could possibly know what's going on with a small planet that's so far away. Well, they study light using a technique called transit spectroscopy. When TRAPPIST-1e passes in front of its star, the light filters through its edges, revealing clues about its air. Repeat enough times, and we start to see what it's really like. That's one of the most important features of the James Webb Telescope. It doesn't just snap pretty pictures. It dissects that light into thousands of slices, each revealing a different clue. It's also great when you remember that E1 is just one of 7 planets that orbit so close. So scientists have a lot to study in that part of the universe. Each transit gives them a little more data, and after enough passes, they can start to rule things out. No thick hydrogen blanket? Check. No Venus-style carbon dioxide swamp? Looking that way. What's left is a planet that might, just might, have something closer to Earth's atmosphere. In other words, nobody's sending probes to TRAPPIST-1e anytime soon. But with telescopes like Webb, we can already peek at its air from across the galaxy. If you follow space-related news, you are already aware that 1e isn't the first so-called Earth-like planet that reached headlines. Astronomers have been teasing us with candidates for years, and each one comes with a but, as in however, not your butt. For example, Kepler 186f. Back in 2014, it was the first Earth-sized planet spotted in the habitable zone of its star. People were really excited. NASA even made a sci-fi-style travel poster. The catch? Oh well, just one minor thing, the fact that it's about 500 light-years away. Even if we build a spaceship that could cruise at a tenth of light speed, which we can't, it would still be a 5,000-year-long trip. Then there's Proxima Centauri b. This one is close, just 4.2 light-years away, orbiting the nearest star to our Sun. On paper, it's a dream. However, its star is even moodier than T1. Proxima exhales massive radiation flares regularly, which makes everything unpredictable and unstable. And then we have K2-18b. The James Webb Telescope actually spotted methane and carbon dioxide in its atmosphere, gases which might hint at biological activity. Sounds great, except the planet is more like a mini Neptune, probably wrapped in thick gas layers and unlikely to have a solid surface to stand on. The bottom line? When compared to all these, TRAPPIST-1e looks like the most promising one. Close enough to study, rocky enough to stand on, and sitting in a sweet spot where liquid water could exist if conditions line up. Of course, we still need more data. 1e could turn out to be a barren rock. But the bigger story is that we're getting better at this. A few decades ago, we didn't know if other solar systems even existed. Now, we've found over 6,000 exoplanets, with more getting added almost every week. Odds are, plenty of them will be rocky, Earth-sized, and orbiting in the Goldilocks zone. Maybe we can't go there, but they could mean the discovery of extraterrestrial life. That's the exciting part. Every time Webb or the next generation of telescopes take a look, we inch closer to answering the big question: are we alone, or is the universe full of neighbors? Hey, get your dog off my lawn.
Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth, in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using 2 powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the 2 other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
This planet, yeah, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. Ooh. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, It's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super-Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
Some time ago, the James Webb Space Telescope spotted a super bizarre space object flying through our galaxy. First of all, it's not orbiting any star. It's a rogue object, just drifting through space on its own. Even better, this wandering thing apparently has a cake-like atmosphere, and examining it can be crucial in our future exoplanet research. Plus, it can help us understand how gas giants evolve over time and what might happen to Jupiter in the future. You may object that Earth has a layered atmosphere too, with 5 major and several secondary layers. But on Earth, the air is mostly nitrogen and oxygen. As for other planets, they're different. Take Venus, for example, where the atmosphere is super thick and filled with sulfuric acid. There are exoplanets with water vapor clouds, or ones where the clouds are literally made of hot sand. But what about our rogue object? By the way, I have no clue why it got this reputation, but for some reason, scientists chose to call it SIMP. Ouch. Anyway, it seems to have its own unique combo, with cloud patches and weird chemical reactions happening high up. It is covered in clouds made of iron and magnesium, and its atmosphere has carbon-based chemicals floating around. Scientists have spotted auroras on it. Yep, like the northern lights we have on Earth, but way out in deep space. It's the very first time researchers have been able to do a sort of weather report on a rogue object like this. The next weirdness? The object doesn't really fit into any box. It's not a regular planet, because it doesn't orbit a star. But it's also smaller than a brown dwarf, which is something like a failed star. So it's something in between. Not quite a planet, not quite a star. And while it's not dangerous in the we're all doomed kind of way, scientists say rogue objects like this could actually mess things up pretty seriously if they wandered too close to a solar system. Their gravity might throw off the orbits of planets, which could lead to instability, or even space collisions. So yeah, while our rogue friend is not a threat right now, it might become one in the future. Now, this rogue object has some crazy stuff going on. First off, its day is only 2.4 hours long. Like, imagine the sun rising and setting in that time. That's real fast. It's also hanging out about 20 light-years away in the Carina Nebula, which isn't super far in space terms. Another thing that makes this guy special is the fact that it's the brightest free-floating object of its kind that we can see from the northern hemisphere. And since it's just drifting in space without a nearby star messing with our view, it's been directly photographed by telescopes, like NASA's Spitzer. That's actually super rare for stuff this faint and far. When scientists checked it out in infrared, aka heat vision, they noticed that the atmosphere of this rogue object was acting weird, like it kept changing, sometimes more heat, sometimes less. Something funky was going on, but what exactly? So, in July 2023, one team of scientists used the James Webb Space Telescope to dig deeper. They pointed it at SIMP and gathered a ton of data, around 6,000 measurements in just a few hours. First, they looked at shortwave radiation, which is kind of like high-energy heat, and then they did the same with longer waves a few hours later. They discovered that the brightness changed differently depending on the wavelength. Some parts of the atmosphere got brighter, some dimmer, and some didn't change at all. It was all over the place, but they noticed a pattern. All the changes fell into 3 groups. Each group had its own vibe, like its own little signature of what was going on in the atmosphere. And it turned out that the mysterious object wasn't just floating alone in space. It was super dynamic, with layers of clouds and gases doing their own thing. It could mean 3 different things were going on in the atmosphere. To figure out what exactly was behind all this, they built models of the rogue object's atmosphere. Apparently, the first group of curves likely came from low clouds made of iron. Yeah, iron, like actual metal clouds. The second group seemed to come from higher clouds made of this mineral called forsterite, which is basically a magnesium-rich crystal. And it looks like these cloud layers aren't smooth, they're patchy. That patchiness could explain why the light coming from them keeps changing so much. As for the third group of light patterns, they weren't coming from clouds at all. The light seemed to be coming from way above the clouds, from what they think are hotspots in the atmosphere. These hotspots are probably connected to radio auroras, kind of like Earth's northern lights, but happening in the radio part of the light spectrum instead of visible light. But even after all that modeling, there were still some mysteries left. Like, the first group of curves was all over the place, more than they expected. So they think it might be because of carbon-based gases like carbon monoxide floating around. They might absorb certain types of light at random times. In any case, this is the first time we've actually seen this kind of atmospheric chaos directly. But the few hours the researchers spent watching it weren't enough to fully figure it out. To really get the full picture, they'll need days of data, and they're hoping to use NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, to dive even deeper. Even though this mysterious object is not a rogue planet, they're definitely worth mentioning. These are basically planets that got kicked out of their home solar system. Yeah, like straight up evicted. When a planet forms, it's usually hanging out with a bunch of other planets around a star. But early on, things can get super chaotic. You know, planets crashing, shifting, getting too close to each other. And sometimes, one gets yeeted right out of the system. So, since they're not tied to a star, these rogue planets are just cruising through the galaxy, totally solo. If they happen to float near something massive, like a star or a black hole, that thing's gravity can tug at them. But otherwise, they just keep drifting. Most of them probably got booted when their system was still forming, and everything was a mess. But according to a NASA scientist, even mature systems can throw a planet out if the orbit gets too weird or something big knocks into them. Now, the next planet we gotta discuss isn't rogue. It has a parent star and all. But there's another cool thing about it. It's still a baby in the middle of forming, and it's pretty rare to catch in action. The baby is already about 3 times the size of Jupiter, the largest planet in the solar system. It's part of a system about 400 light-years away. It's been growing for about 5 million years, munching on gas and dust from the disk around its star, kinda like a cosmic buffet. But the thing is, when astronomers checked out the chemicals in the planet's atmosphere using a big telescope in Hawaii, things didn't add up. They were specifically looking at carbon monoxide and water, which can help figure out how much carbon and oxygen is floating around in that atmosphere. Turns out, the planet's chemical mix doesn't quite match the stuff in the disk it's forming from. That's a big deal because it goes against what scientists thought they knew about how planets are supposed to form. Basically, it's saying, hey, your fancy models might be a bit too simple. Planets are supposed to form by clumps of gas and dust crashing into each other and sticking together. Over time, they build up into full-blown planets. If that's true, then planets and their surrounding gas should have the same kind of stuff in them, chemically speaking. But PDS-70b is doing its own thing. So the scientists came up with 2 ideas to explain what was going on. It might be forming from solid stuff, like dust and ice, not just the gas in the disk. That solid material has carbon and oxygen trapped inside. So, by the time it melts and goes into the planet, it's already changed the chemistry. Or the gas in the disk got more carbon after the planet already formed. Luckily, there's another planet in the same system, PDS-70c. And scientists are hoping that by checking it out too, they'll be able to figure out the truth.
You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of. Currently, who knows what else is out there? The Virgo cluster is also unusual as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the sixth brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there?
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to higher-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the Moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Perhaps we've all stopped to think at one point about what it would be like to live on another planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the stars in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they have found a new planet that might be able to support life. They call it TOI 700e. E is roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they call TOI 700d, but this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the conservative habitable zone. In simple terms, scientists aren't sure whether life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have some options. The two planets are in a solar system that's only 100 light-years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space and thrive for long periods of time. And history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technologies help us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it could take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, supersonic aircraft, but it's not the same. There's quite a difference, actually. Light is about 1 million times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that's not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go up to about 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret Option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh. Instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets in through the windows every day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life. But if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. So the next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, we don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low. But if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off of their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then, that would be a bad thing too.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface. which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, It would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from